Hello students, this is a maths worksheet 50. This is a revision worksheet of chapter number 6, factors and multiples. Here we will discuss HCF and LCM and factors and multiples. Now students, here I solved some examples related to prime factorization. We will revise here the factor tree method. The first question is, find the prime factorization of 120 by factor tree method. So here first we write the number to be factorized at the top. So first we write here 120. Then choose any pair of factors as branches. If either of these factor is composite factors, and factorize again. So here now we factor this 120 in two parts. 4 3s are 12, 40 3s are 120. Now here again we factorize this 40. So 22s are 40. So again we write this 3 here, and between these we mark multiply symbol. Now again we factorize this 20. 2 10s are 20. Now we write 3 as it is here and 2 as it is here. Now we write this 3 and 2 as it is here. Now we again factorize this 10. 2 5s are 10. And write this 3, this 2 and this 2 as it is. Therefore the prime factorization of 120, and we write these numbers in increasing order. So first we write 2 multiply by 2 multiply by 2, then 3 and then 5. We write these numbers in increasing order. First we write 2's and then 3 then 5. So the prime factorization of 120 is 2 multiply by 2 multiply by 2 multiply by 3 and multiply by 5. Here we also factorize this number 120 in another way and make factor tree of this number. So first we divide 120 by 2, so we get 2 multiply by 60. Then we write 2 as it is here, then divide again this 60 by 2, we get 2 multiply by 30. Then again we write 2 as it is here, 2 as it is here, and then again divide by 2, we get 2 multiply by 15, or we all know that 15 2s are 30. Then again we write 2 as it is here, then 2 as it is here, then 2 as it is here. Then we divide this 15 by 3, and 3 5s are 15. Now there is no other factor of this 5, so we write these numbers as factors like 2 multiply by 2 multiply by 2 multiply by 3 and multiply by 5. Now students, here we will revise continuous division method to find prime factorization. Now here we find prime factorization of 120 by using continuous division method. Here we write first number which factorize here. So write 120, then divide 120 first by the smallest number like 2, then 3, then 4, then 5. Then first we divide here 120 by 2. 2 6 are 12 and write 0 as it is here. Then again the 60 number is divisible by 2. So we divide this 60 by 2. 2 3s are 6. Now again number 30 is divisible by 2. So we divide by 2 this 30 15 times. 3 1s are 3 and 3 5s are 10. And again we divide this number by 3 because 15 is not divisible by 2. So we divide this 15 by 3. 3 5s are 15 and 5 divisible by 5. 5 1s are 5. So the prime factorization of 120 is, therefore the prime factorization of 120 is 2 multiply by 2 multiply by 2 multiply by 3 and multiply by 5. So these are the prime factorization of 120. Now students, here I solved some examples related to highest common factor HCF. Here we discuss the first method by listing factors. We also discussed in the previous lessons HCF and now we revise it again. Now students, here I solve example, find the HCF of 12 and 40. So we apply a rule by listing factors here. So first we list all the factors of each numbers 12 and 40. So first list all the factors of each number. Now factors of 12 factors are those numbers which divide this number without any remainder. So the first number 1, 2, 3, 4, 6 and 12. Now the factors of 40. Factors of 40 are 1, 2, 4, 5, 8, 10, 20 and 40. So here identify common factors. So the common factors are 1, 2, 4 and there is no other common factor. So we write the common factors. Common factors are 1, 2 and 4. Out of these 1, 2 and 4, 4 is the largest. So the highest common factor HCF of 12 and 40 is 4. Now students, here we will revise find highest common factor by using prime factorization method. So example, find the HCF of 20 and 35. Now in this method we find the factors of 20 and then factors of 35. So first we find factors of 20. Factors of 20. So factors of 20, we find factors of 20 by using division method. So we write 20. Now 2 10s are 20, then 10 divided by 2, 2 5s are 10 and then 5 1s are 5. So the factors of 20 are 2 multiply by 2 and then multiply by 5. Now we find the factors of 35. Factors of 35. So first we divide this 35 by 5. 5 sevens are 35 and 7 ones are 7. So we write factors of 35, 5 and 7. So HCF is the product of common prime factors. So first we find common prime factors. 5, only 5 is common here. So we write therefore HCF of 20 and 35 is 5. Now students, here we will revise method number 3, finding highest common factor by using division method. Example, find the HCF of 4, 16 and 20. We find first divide the numbers by common factors only and stop dividing when there are no more common factor except 1. First we divide these three numbers by 2. 2 2s are 4, 2 8s are 16 and 2 10s are 20. Now again we divide this number by 2. 2 1s are 2, 2 4s are 8 and 2 5s are 10. Now there is no other common factors which divide these numbers, the only number 1. Therefore HCF of 4, 16 and 20 is 2 multiplied by 2. 2 multiplied by 2 gives 4. So 4 is the HCF of 4, 16 and 20. Here we will revise multiples. A multiple of a whole number is the product of the number and any counting number. So we can state some multiples of 2 and 11. So the multiples of 2 is 1 multiplied by 2 is 2, 2 2s are 4, then 3 2s are 6 and 4 2s are 8, like multiples of 2. And multiples of 11, 1 multiplied by 11 11, 2 11s are 22, 3 multiplied by 11 33. So these are the multiples of 11. Some properties of multiples are every number is a multiple of 1. The smallest multiple of any number other than 0 is the number itself. Every multiple of a number is greater than or equal to that number. The number of multiples of a given number is infinite. These are some properties of multiples. Friends, here we revise least common multiple or LCM. LCM is the smallest number other than 0. That is a multiple of 2 or more counting numbers is the least common multiple LCM of the numbers. It is the least number which is divisible by all the given numbers. So first we discuss method number 1 by listing the multiples. Now the example, find the LCM of 3, 6 and 12. So first we write the multiples of each number. So the multiple of 3, first we write the multiple of 3, then multiples of 6 and then multiples of 12. So first we write multiples of 3. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39 and so on. We also write as a table like 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12 and so on. Now the multiples of 6. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, and so on. Now we write the multiples of 12. The multiples of 12 are 12, 24, 36, 48, and so on. So now first we identify the common multiples. Some common multiples of 3, 6, and 12 are like we check which are the common multiples in these three numbers. So first we mark 24. 24 is here and here and here also. And the second number is 36. 36 here and 36 here, 36 here. So we write 24 and 36 and other number also. So here pick up the least common multiple from the list of common multiples out of these common multiples. So 24 is the least. So therefore the least common multiple LCM of 3, 6 and 12 is 24. So the LCM of 3, 6 and 12 is 24. Students, here we will discuss another method, method number 2, finding least common multiple or LCM by prime factorization method. Now student, we solve examples related to LCM and using prime factorization method. So find the LCM of 32 and 48. So here first we find and factorize the given number by prime factorization method. So first we factorize number 32. First we divide 32 by 2. 2 ones are 2 and 2 6 are 12. Then 2 8s are 16 and again divide by 2. 2 4s are 8, again divide by 2. 2 2s are 4 and again divide by 2. 2 1s are 2. The factors of 32 are 2 multiply by 2 multiply by 2 multiply by 2 and multiply by 2. Now we find the factors of 48 by using prime factorization method. 48. First we divide this 48 by 2. 2 2s are 4 and 2 4s are 8. Again divide by 2. 2 1s are 2, 2 2s are 4. Again divide by 2. 2 6 are 12. Again divide by 2. 2 3s are 6. Then this 3 divide by 3 only. 3 1s are 3. So the factors of 48 are 2 multiply by 2 multiply by 2 multiply by 2 and 3. Now multiply the common factors and the extra factors to get LCM. So first we find the common factors. Here pair of 2 is common, here pair of 2 is common, here pair of 2 is common, and this pair is also. We will multiply the common factors and the extra factors to get the LCM. So LCM equal to 2, we take 2 from here and multiply by 2 and multiply by 2 and multiply by 2, and now we write 2 and 3, 2 and 3. Then we multiply these numbers. 2 2s are 4, 2s are 8, 2s are 16, 16 2s are 30, 2 and 32 3s are 96. So 96 is the LCM of 32 and 48. Here we will revise find least common multiple by using division method. Example, find the LCM of 16, 28 and 46. Now we write 16, 28 and 46. Now we divide these numbers by 2. First we divide 2, then 3 and so on. So 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 2s are 4, 2 3s are 6. Now 2 4s are 8 and write 23 as it is here, then 2 2s are 4, then 7 and write 23 as it is here, then again by 2, 2 1s are 2, then 7 and 23. These both number divide by only itself. So we write LCM of 16, 28 and 46. So we find the product of the numbers in the left column and the last remainders. 7 and 23. So we write 2 into 2 into 2 into 2 multiply by 7 and 23. When you multiply these all numbers, we get 2 2s are 4, 2s are 8, 2s are 16, 7s are 112. And when we multiply 112 by 23, we get 2576. Here I solve example and word problem related to HCF. Two wires are 12 meter and 16 meter long. The wires are to be cut into pieces of equal length. Find the maximum length of each piece. So first we write the length of a first wire. (12 meter) and length of second wire equal to 16 meter. We find HCF of these both measurement number 12 meter and 16 meter by using division method. Divide large number by a small number. So 12 divide 16 one time, 12 ones are 12 and 6 minus 2 4, we write 0 here, then again here 12 is divisor and 16 is dividend. So 12 take a place here as a dividend and 4 is a divisor here. So 4 3s are 12 and the last divisor is the HCF of these both number. So HCF of 12 and 16 is 4. 4 meter is the maximum length of each piece. Next example, this example related to LCM. Determine the lowest natural number which when divided by 16 and 28 leaves remainder 3 in each case. So here first we find LCM of 16 and 28. So LCM of 16 and 28. Now 16 and 28 divide by 2. 2 8s are 16, 2 1s are 2 and 2 4s are 8. Now again divide by 2. 2 4s are 8 and 2 7s are 14. Now again divide by 2. 2 2s are 4 and write 7 as it is here. Then 2 ones are 2, 2 ones are 2 and write 7 as it is here. Now divide by 7, 7 ones are 7. So LCM of 16 and 28 is 2 multiply by 2 multiply by 2 multiply by 2 and 7, and we get 2 2s are 4, 2s are 8, 2s are 16 and 16 7s are 112, and hence the required number which divide by both number and leave remainder 3. So hence the required number is 112 plus 3, and 112 plus 3 115. So if we divide 115 by 16 and 28, so it leave remainder, these both number leave remainder 3. Dear students, in this exercise I give some questions related to our discussion. So you will do all these questions in your homework. Thank you students.